A teacher again. Okay, part D. This finishes off yesterday's video. I'll post it on your Tuesday. No, what is today? Wednesday. I'll post it Wednesday though, and so there'll be 2 videos there. This is called rearranging equations. Actually, it worked out good. I didn't do it on purpose. It worked out good that you were able to go home and do a little equation solving, get that down pat so you could see this after that. There are 2 forms of linear equations. And the only reason I bring that up, because I'm just going to put that word there, even though you don't have to write that down. We're going to talk about other types of equations this year. It's coming soon. But for a while, we'll stick to what are called linear equations, which means if I graph these types of equations, I'll see a straight line. Hopefully, they beat you to death with that in grade 9. Yeah, where it's like, well, I don't remember all the details, but I do remember there was a lot of lines on the page. Okay, and we're gonna pick it up there, and we'll start with that, and then we'll do some other things. So there are 2 ways to write that, something called standard form, although it's not standard at all. There's other ways to write this. Essentially, it looks like this: ax plus by plus c equals 0. Maybe you didn't see that in grade 9. I'm going to talk about it today. Please don't pretend it's going to be something difficult. It's not. I'll show it to you in just a minute. But this is the one you should have seen in your nightmares again and again. It might be the MVP from grade 9, the most important equation you got going. Although it wasn't that complicated, actually, once you got down to it. Y equals mx plus b. And I'm going to talk about it here in a minute, and a little more in the next video or the next lesson that I'm going to do. In order to determine the slope and y-intercept of a line, the equation must be in the form y equals mx plus b. In fact, this might be your Valentine. When it's written like this, life is pretty straightforward. Okay? If you don't think so, here comes the explanation again. Life's pretty straightforward if it's written like this. But y equals mx plus b gives it, like it makes it look magical or difficult. I'm just going to write beside that, what we mean is, it'll look like y equals. Y is isolated on the left side. That's the important detail there. I mean, there's some other stuff going on there, but the important thing is y is by itself on one side of the equation. Not to get sidetracked, but when I said, well, on one side of the equation, you might be like, no, it's got to be on the left side. I'm like, well, yeah, I guess so. Left is convenient, for sure. But it doesn't have to be the left side. So, once it's in y equals mx plus b form, the m will be the slope, and the b will be the y-intercept. You're like, which one's which? I forget how to do it all. I know, it's the next lesson. Don't panic about all that just yet. But this is just a reminder that we like y equals mx plus b form. Another way to write that whole paragraph would have been me to say, we like y equals mx plus b form. Yeah? Forget the details. We like that better. Okay? If the equation is in standard form, you should, it says must, should. I'll put should, okay? Because you're an AP class, and I'm like, there's a long way to go here. Maybe there's reasons to write it like that instead of like this that we don't know about yet. But let's stick to the grade 10 version. The grade 10 version says you're going to want it in y equals mx plus b form. To isolate y on the left, ooh, that's the best sentence, that's the best phrase yet in that whole page. If you've slept through all that, if your brain's not locked in, at least underline that phrase or highlight that phrase, isolate y on the left. That's the important detail we want out of all that. So here's a few examples of how we do that. Okay? On the left, I've given one that's in standard form, even though I must tell you, there's nothing standard about it. Some people act like it's a standard form, but there are many standard forms depending on what you're doing. So, to get from standard form to y equals mx plus b form, well, what I would do is underline the y term and have a long stare at it and go, well, I only want y on that side. Everything else has to move over. And you can use the steps, and I was interested to see the different versions that you had. What was going through my mind when I did the homework check might be different than what you thought. You might have been thinking, oh, he's checking every single question. No, I was checking how you were doing things so I know what to say next, yes? And I did see some people do this, where they took negative 12x plus y plus 15, or whatever equation they were working at, and they went over here and they wrote beside these terms plus 12x, and then they wrote plus 12x over there. It's a very powerful way to do it. Some of you who are really smart might think, oh, I can do it in a faster way. Well, you're right. It's very clever to do it without the extra steps. That doesn't necessarily mean it's better. and then subtract 15 from both sides as well. And what I get is y equals positive 12x minus 15. Both of those changed their sign, right? Negative 12x is now positive 12x. Positive 15 is now negative 15, making some people believe that you change the sign when you move it over. And that's not true at all. You change the operation. This happened to be adding 15, so it became subtracting 15. So just a little mention of that. Does that ring a bell from grade 9? Or at least now that you've seen it here, you're like, oh, this is just what we were doing with solving equations, except our goal is to get y over here. Apparently, we're going to like that when we go to graph these things. More about that in a few minutes. So this one's very similar, and I'll do this. I did this one that way, and then I'll do this one the way I saw some people doing it, and I'm with you. If you're out there going, I don't need the extra steps. In fact, the extra steps confuse me. Don't I just take those terms, like negative 8x, and I bring it over here, and I make it positive 8x. And the positive 10, when it becomes over, it becomes negative 10. Isn't that all we're doing here? And they're a little confused by me showing the extra steps. Well, I'll give two answers to that. One is, yes, you're right. That's exactly all we're doing. We're just moving them over. But also say, those of you who are considering the possibility of being a future teacher, you better know both ways to be able to help people out who see it differently. Yes? There, all done, right? It's not done. Hi there.
Hi.
Welcome. Oh, what do you want? Regular line? Yeah, take all you want.
Please, thank you.
I just ordered lots more, so you can take as much as you want. Yeah. Is it done? Is it done? No, it's not y equals. It's 2y equals. Does that matter? Oh, it really matters. So how do I get rid of that 2? Yeah. And I'll show the step this time, but some of you might not be showing the step, and that's okay. I'm going to divide both sides by 2. That's really what equation solving is all about, doing the same thing to both sides. The result of that is the multiply by 2 disappears on this side, and you get divide by 2 on that side. You can leave it like that, but that's not going to be the way we're going to want it for graphing. We're going to want to divide each of these things by 2, so I get 4x minus 5. Now I'm very happy. I'm ready to graph. I forget how to graph. Yeah, okay, no problem. We're going to do that next. What do I do with this next? And we'll talk about that in a few minutes. This is the algebraic side of it. How do I get it set up to graph? And then once I have it set up, then I can go through and actually do the graphing. All right. So one more to go, but let's not wait around to tonight to find out you can't do these. This is the toughest one on the page. You take a moment and try to get y by itself. This one has some curveballs in it. So take a minute or two, try it out, and see what you end up with. A mistake is good. If you get a mistake, if you make a mistake, then at least you learn from it now, not tonight when you're sitting there at home. Like always, I will go up after a couple minutes and start doing it. So if you're having trouble getting started, you can just take a look and see what I did. Well, this is a stressful situation, isn't it? Negative 3x over negative 4. Negative 3 over negative 4. It's going to be a fraction. I'm stuck with a fraction. But is there any way to simplify that fraction? Could I leave it as negative 3 over negative 4? Is that correct? And the answer is yes, but it's sort of inconvenient. Negative 3 over negative 4, those two negatives will cancel, and you actually get positive 3 over 4. Just easier to work with, not necessarily what I would say. Oh, it is a better answer. I almost said it wasn't a better answer. That's not true. It is a better answer to go positive 3 over 4. And if it's bothering you a little bit that I put the x out to the side, I like that that's bothering you a little bit. You're like, you can just put that out there? Yeah. 3x over 4 is the same thing as 3/4 x. And now that 3/4 is over there by itself, and I can use it when I go to graph. That's the slope. This other fraction is 6 over negative 4, but now I defer to somebody else. What will the other number be if it's 6 divided by negative 4? Will it be positive or will it be negative? First of all, it'll be negative. And yes, 6 over 4 is, yeah, and we could go to decimals. And that answer, I'm pretty sure that question didn't get answered in grade 9. It's perfectly fine to be sitting there right now and going, I don't know why we would use a fraction over a decimal and why we would care about reducing. It's okay to be confused about that right now. I know how to reduce the fractions. I know how to make them into decimals. But I don't really get why you choose one over the other. That'll be part of my job this year is to go, let's just talk about this and why we would do fractions over decimals. I'll write down the answer and then I'll AP it up a little bit here and give you a little bit of information about that. 6/4. What does that reduce to? 3 over 2. And we like the lowest form of a fraction because it's easier to work with. Now I must tell you, speaking to you as APs, that if all the fractions were halves, no one would have invented decimals. Halves are very friendly fractions. So this is our first level of wisdom about fractions. If it's halves and quarters, decimals probably aren't necessary. There's probably no reason to do decimals. That's an exaggeration, but sort of true. But thirds, problem. Thirds are a problem. 0.33333. When do we start? How many decimal places do we keep? We're like, oh, 2 decimal places is enough. I'm like, oh yeah? You go to build an iPhone or the engine of a car or launch a rocket into space to put a satellite in the right position, 2 decimal places is not going to cover it. 1/3, fairly friendly. 1/6, and then type 1/7 in your calculator and you'll see there's some very unfriendly fractions out there. And that's why we practiced fractions. And so would this one be perfectly fine as 1.5? Yeah, it probably would be. It probably wouldn't affect anything we're doing. But we practice on all the fractions, getting ready for when the fractions get crazy. There's a little bit of wisdom. I'm going to do this another way, though. Maybe I could move the y over to the other side. That solves all my negative problems. So potentially you could be like, I'll put the y on the side that makes it positive to save myself a little bit of negative nonsense. I'm not suggesting you do it. I'm just saying that's out there. And before we're done at the end of grade 12, we will start doing moves like this to go, how about if I just move it over here? And then you divide by positive 4, saving yourself a lot of headaches because the numbers might look a little more friendly there. Is that a really good move? I don't know. That's not that great. And this annoys people. And your grade 9 teacher might even said, you put y on the left-hand side. And they're right, except it's okay. It's all right. It's not the end of the world to put y on the right-hand side. But if that scares you, don't do it. All right? If that bothers you. Never do it if you don't want it. This chart asks you to go the other way, which I'm not too worried about at all. We don't very often in grade 10 or 11 go the other way. Once it's in y equals mx plus b form, we're pretty happy. But if I had to move it over, this would become negative 2x plus y plus 5 equals 0, and I've moved it all over to one side. Is there a good reason to do that somewhere in the history of mathematics? Yeah, there probably is, but we're not going to face that too much, you know. And so this one too, you could move the 3/5 x and the negative 6 over, and it would become negative 3/5 x minus y plus 6, or sorry, plus y plus 6 equals 0. The y is still positive, but the 6 has become positive when it moved over. I need to tell you though, most resources that have standard form also have a rule that says no fractions in standard form. We're not going to hold you to that in grade 10. But most times when you actually see standard form, they tell you not to have fractions. And to get rid of the fractions, I'd have to, what would I do to get rid of all the fractions here? Multiply everything by 5. And if I multiply everything by 5, I get negative 3x plus 5y plus 30 equals 0. That's closer to what's considered standard form for these linear equations. But it really doesn't come up until the second half of grade 12, those type of things. I just mentioned them here so that these things are correct on my screen. We're mostly going left to right. Now that's really what we're going to be about. We want y equals mx plus b, and you'll see in just a few minutes why we want that. Okay? Do you have any questions about that? I'm going to answer yes, that we will avoid decimals whenever we can. For now, I give you two little side rules about decimals. In grade 10, the only time you should go to decimals is if the question starts with decimals. It's giving you freedom to do decimals. Or you're dealing with money. Decimals are built into the system. Okay? Later on, we'll find out if we're measuring things, like the height of a tree, then we'll go to decimals as well. Besides that, we'll practice fractions. And I'll tell you why. I just finished teaching grade 11 university math. And they're having some awful time with the algebra. They're getting tortured by the algebra. And the main issue is their inability to handle the fractions. So for that reason alone, it is my job to keep you on fractions so when the fractions get more difficult, you'll be ready for them. Like, how could fractions get more difficult? This is the kind of thing they're dealing with in grade 11 and 12. And now the fractions just got a lot wilder, and you better know what you're doing with fractions before you run into something like that. So that's one of the reasons why we keep you to fractions in grade 9, so when you get to grade 11, you got a chance. Okay? Good question. Other questions for me?